Welcome, everybody, to the Thoughtworks Technology Podcast. My name is Scott Shaw. I'm one of the hosts of the podcast. And today we are going to talk to some friends of mine here in Melbourne, where we all live. And the topic is going to be their new book, which is called Effective Machine Learning Teams. I think that's particularly relevant in today's technology landscape. I'd like to have each of the participants introduce themselves and tell us a little bit about themselves and the perspective they bring to the book. But first of all, I want to introduce my co-host, Ken Mugrage. You want to introduce yourself? You want to tell us a little bit about yourself, Ken?
Sure. Hi, everybody. I'm one of your other regular hosts and the only person on this team that's not only not in Melbourne, but not even on the same continent. Actually, not even the same day. So welcome.
We're greeting you from the future. Okay, so yeah, if you all would start, David Tan, why don't you go first?
Cool. Thanks for having us, Scott and Ken. So I'm David Tan. For deduplication purposes between David Colls and David Tan, I'm David, and yeah, Dave has generously become Dave for our collective, reduce the confusion. So yeah, I'm a lead machine learning engineer with Thoughtworks, and I've been with Thoughtworks for 7 years. And through this time, have been fortunate to be able to work on data and AI systems, help clients build, various machine learning models in one time, building an ML platform. And yeah, really happy to be here to chat about effective machine learning teams.
And what unique perspective do you think you bring to the book amongst the three authors, David?
Yep. I love engineering. It's something I can touch and feel and deploy and write and commit. So I think in this book, I bring a lot of that ML engineering perspective in the intersection between software engineering and ML systems.
Great. Thanks. And Ada, why don't you introduce yourself next?
Hello, my name is Ada, and no, I'm not named after Ada Lovelace. I think that's a random fact about myself, but I've been at Thoughtworks just over 6 years. My role is a senior business analyst or product owner or scrum master, the type of roles that we go on and work with clients where we bring people together, and I think that's where my specialty is, bringing people together, building that shared language, but also delivering value and showing that we can deliver quickly as well. So de-risking delivery and yeah.
Thanks. And Dave Colls, why don't you go now?
Thanks, Scott. Yes, nearly a palindromic triad for the three authors, but I'm going by Dave for disambiguation. I've been at Thoughtworks about 13 years, and in that time I've worked in almost every aspect of the business and every service we offer to clients, from project management to business analysis to infrastructure to data science. And in the last 7 years, I've been building the data practice in Australia. And in that regard, my focus has been on not necessarily the detail of technical practices or data, but creating environments for teams to be successful. And I think that's the perspective I bring to this book. What can we do in the wider organization to create a successful environment for ML teams?
This is the first time I've heard the phrase palindromic triad used on one of the technology podcasts. So thank you for that. I'll be looking it up later. So let's get started. How did you come to write this book? It's a big endeavor. Writing a book is a big job, one that I would be daunted to undertake. And I wonder, how did you come to write this, and why a book?
Yeah, I think it was a series of events. It started all with a blog post that in 2019, like just finishing off a project. It was a blog post I wrote about refactoring Jupyter notebooks from that project back then. And then that kind of blew up on Twitter. Someone in our community shared it, and there was like, 800 hearts, which to me was a lot, most I ever got on Twitter or X. Then it became a repo that had like 600, 700 stars. And once or twice we ran it as a workshop in Thoughtworks Singapore with AI Singapore. And the feedback we got from folks who attended was like, oh yeah, this intersection between ML and software engineering wasn't talked about enough. Like how do you test models? How do you refactor notebooks? So we got those kind of feedback points. They said, okay, we're onto something here. So yeah, then we eventually put together a book proposal, and yeah, O'Reilly accepted it. And so yeah, it's been a journey of fleshing out those points about how do you build reliable systems, ML systems? How do you get feedback? How do you apply product thinking? How do you test your ideas with users? And yeah, that's how it came to be a book there.
And Ada and Dave, how did you get involved?
David reached out to me and said, hey, would you be interested? And I said, yeah, why not? And I think that's always my default if I haven't done something before. And the previous writing experience I've had was publishing a Thoughtworks blog on slicing data stories. So it was a big jump, but at the same time, it's been such a hell of a ride, distilling my thoughts and moving from implicit knowledge to something that is shareable. So I think that's the journey has been quite rewarding as well.
Yeah, there's been so much written about machine learning technology. And in my experience, I guess, the things don't get actually done unless you have an effective team to put it together. And so I'm really happy to see that perspective represented in here.
Yeah, and I think that was exactly how I got involved in the book, having had the good fortune to work with David and Ada in the past, and see the reception that David's coding habits for data scientists and other resources had generated. I really wanted to highlight that it wasn't just about an individual contributor perspective, that the practices and tools that he was advocating for were really there to enable whole teams to deliver effectively.
So I'm curious if I could, you each had a lot of experience in your own particular roles. How different was what you thought you knew versus what you learned you knew during the writing process? Sometimes, I got a good handle on this. Then you start researching and, oh my gosh, I mean, was that a big leap or was it incremental? Did it just kind of bounce off each other? What was that like?
Yeah, I think that's a great point. And the story I've been telling people is that I started writing this book with Ada and Dave, going in thinking like, wow, I know so much about machine learning from past projects. I want to tell the world about it. And through writing, I was like, oh, there's so much I don't know. So I think through that literature review, through testing ideas with whether on a project or through our technical reviewers, and we have a kind of panel of other reviewers with experience in other domains and ML technologies. So through that, it's been a lot of growth, a lot of learning. And even through literature review, one of the books that I read was Atlas of AI by Kate Crawford, which was like a whirlwind tour about responsible AI in application. So there's just so much in any of those subtopics or branches in the domain of ML. So yeah, I think writing definitely helped to make out, at least personally, my knowledge more robust. Ada?
I was thinking about how we've collectively been on different engagements, client engagements, and we've been on ones together. And was it a big leap? It felt like it was, in a sense that the book was one engagement and, do we have the experience from end to end? But equally it wasn't, because we've collectively been on different types of client engagements, like fast experimentation with ML, productionizing a POC, ML POC that was just thrown into production. And so in some ways it wasn't. It was just collecting and rehashing our memories, and it was kind of fun going down memory lane together.
And I think there's an aspect of it that is like testing and extending what we know. So we had an idea for a chapter about automated testing for ML systems. Through writing that, we were like, okay, yes, you can write an automated test for an ML model using a global metrics test. But then through that, we discovered, okay, there's the hidden stratification problem where maybe the model is 70% accurate, but actually for a particular subclass is totally rubbish, like maybe 40% accurate. So, through testing and through checkpointing our knowledge with the working example in the book, a code repository, then we kind of refined, how do you fully test ML systems and monitor it. So yeah, I would recommend blogging or checkpointing has been a really helpful exercise to consolidate that knowledge.
So can we assume that the kind of fictional scenarios that are depicted in the book are actually things that happened to you, that really happened, and that you've observed on real projects?
Often they're amalgams of different things as well. So yeah, there's they're based on a true story, as it might be said.
Yeah, and in our book we followed the arc of this fictional character called Dana, who's a data scientist or ML engineer. So somewhere in the book we say the character is fictional, but the pain is real. So like we follow her, and throughout it's basically versions of Ada, Dave, or myself, in various scenarios where, there's a story in there about, deployment day, release day. We have a lunch party organized. We're going to celebrate the release of this new ML model. And as she is there with the infra engineer to try to deploy this thing, deployment fails, and then before you know it, it's like the troubleshooting, and it's like 7 p.m. and they have to go to this lunch party feeling kind of guilty, actually the ML model's deployment failed. So we try to bring our experience to life in this book through these kind of story snippets that hopefully people can relate with.
Is there an overall message? Are there a few key sort of takeaways that people are going to get from the book?
I think for me, it's about great ML products require effective teams to build. And when you look at team effectiveness and the way we've broken down the book in broad terms, we've broken it down into sections that focus on building the right thing. So understanding the right business problems to solve, where you have access to the required data and where an appropriate ML paradigm exists for a successful product to be built. Then we focused on building the thing right, so the practices that will enable you to manage complexity and to maintain responsiveness in delivery. And then the third element has been building it in a way that's right for people, as we've described. So, a lot of those stories indicate the pressure and difficulty that the teams can have working in these highly complex environments with many different demands. And so we're looking at what can we do to relieve the cognitive load on teams, to create safety nets for delivery, and also to align their work with value streams within the organization so that they're not blocked on getting value to customers.
I know I've seen, especially in the early days when organizations first started embracing machine learning, they formed, if you were talking about a machine learning team, you were talking about a team of data scientists, and they always kind of sat separately from the main engineering department and the product people. I'm assuming you're talking about cross-functional teams here, and teams where data science is embedded into a larger product stream. Do you see that changing in the industry?
Yes, absolutely. I think data scientists in nature are very curious creatures as well. And people like to understand the bigger picture of why, not just how a model is put together. And the answers to why is usually sitting with product owners or business analysts or business-shaped folks with that context and who are close to the end consumer or customer. And that can be an internal one or an external user as well. And I think that contextualizes it and makes it human in terms of how usable and then therefore how valuable what we're producing is. We do see the added increasing pressure of, this return on investment, for example. There's a lot of investment going into these spaces in organizations, and being able to demonstrate it in a showcase where you can see the impact, not just showing a feedback loop and the data being collected and how it's being retrieved. I think that is what gets everyone else in the organization interested and then on board with ML-driven products.
So question, 2023 was the year of the hype around generative AI and so forth, and it's not going away anytime soon. But would you think that, that aside, is some sort of machine learning a part of what percentage of projects would you say? I mean, my impression is it's very, very high, but I'm curious what your real world experience is.
Without putting an exact figure on it, very, very high from our experience as well. And in different aspects in that ML might be incorporated purely as a service into a digital product from a third party or from another part of the organization as a starting point. And so it's still useful for teams to understand what goes into building ML services in that regard as well, and how they might fail, and how to properly test products that incorporate ML services right through to in-house built ML products where proprietary data training processes and deployment of the models are all taken care of in-house. And so, we're seeing a very high proportion of products especially as organizations move and to provide more convenience features in digital products. So a lot of those convenience features are driven by ML. Insights. If we look at digital marketplaces, often we're looking to provide insights to both sides of the marketplaces, and a lot of those are driven by machine learning as well. So, we're seeing the application spreading, and then we've also got generative AI wave now currently as well. So a lot of in those cases mainly integrated in that first mode as a service, but we'll probably see as the tooling improves and we're able to build smaller, more dedicated models, we'll probably see some more of that coming in-house as well.
Yep. My read of the ML landscape today post the 2023 hype or boom of generative AI, as you mentioned, Ken, is I see a long tail of if we plot an y-axis of number of ML practitioners like ML engineers or data scientists, if you do a count of that, I think it's a long tail where you have a long tail of orgs with perhaps one or two, maybe three data scientists or ML engineers. And then there's the chunky middle part where perhaps you've evolved and become more mature. You have a full data science team that's servicing multiple varied needs. As Dave mentioned, maybe it's insights, maybe it's language models, maybe it's personalization. But then there's the third part, which is the very few but deep organizations with multiple data science teams. Could be, I've heard numbers of 100 plus data scientists, could be ranging from 20 to 100. So I think all the more it makes it important in order to reduce the frustration of these practitioners, of people who have hopes on these ML products going to the market, that these product and engineering and team topology practices, they become more important to help these teams to be able to move towards a goal. Let's say it's about building a recommender system or building an insights report using advanced analytics. So it's very common to see some teams cycling around like POCs after POCs that just are not maybe good enough or don't have a market for it. POCs are good. It's a great way to test ideas. They also over time kind of make practitioners quite frustrated over time when you don't see things going out into the market. So we talk a lot about practices to test these ideas early, so that when you start to really build and productionize something, it is something that's fit for market. There's a product market fit, there's a problem solution fit, and how do you build that rapidly using engineering best practices?
You mentioned something that David, that I wanted to go back on, and that is shared goal. And while we see, can you ask the question, how much of Gen AI are we seeing out there? We see a lot But also the risk is also high in terms of are we really getting our return on investment? Because you have a lot of the tools there, but what is that saying? If you have a hammer, everything looks like a nail. And if we're not clear on that shared goal, and we're not clear on what customer problem or value we're trying to create or get back because of market competition, then we are seeing what David mentioned is lots of POCs just cycling through and forever being in discovery. Not always a bad thing. I think statistics with the big tech is 95% of POCs do fail. And it is important to keep on going, but it's also equally important to have a shared goal and vision and also a clear idea of what kind of problem or value we're trying to solve.
If I may, I'll come back to the question on team shapes as well. And, is it a multidisciplinary team or is it a group of data scientists? And so I think that in the early days of data science and machine learning exploration in organizations, they saw data science as the key problem to solve. And it certainly is one of the key problems to solve in many ML teams. But while it's necessary, it's not sufficient. We also need to have a business problem, a product lens. That's another element. And we do need to be able to connect insight or intelligence to action in organizations as well. And so, we might be working with teams of data scientists who could build great predictive models, but it wasn't possible for that to actually influence a customer experience in deployment in the organization, so that there wasn't an opportunity to deploy it into production, or production systems were unreliable to the extent that offers weren't being fulfilled, and so the value of those better targeted offers wasn't being realized. And so then the question comes back to how do we solve this with a team construct, and that's where we see, and I think Thoughtworks heritage has been around delivering value end to end in short cycles, and especially and there's established literature around the innovation potential of multidisciplinary teams as well. So if you're looking to do something new, then that's where a multidisciplinary team really shines. And so that's kind of been our default unit. But, one of the great things that came out from the book was some time and space to explore the various team shapes for machine learning and what role they might play in a larger enterprise. And so we've still been able to articulate, what's that team shape that's mainly composed of data scientists? Where might that play a role in a larger enterprise, and how might you make that team effective?
So you mentioned product thinking and building products and the importance of understanding the customer. What else? What does it take to make a great machine learning product?
Yeah, what does it take to make a great product? And product development is hard. I think it was Henry Nieberg from Spotify that says, product development is hard. Most products fail. And that's the reality of it. And in ML, I suppose we are reminding people that shiny hammers, looking for problems, don't always, and most of the time, if it's not solving a real problem, then the return rate of your users are not going to be great. Like you may get a high hit rate at the start, but it's not a solid or defensible product. One aspect that we talk about is just that lean discovery approach. So just to focus on what that problem is, and it may turn out that it's not ML, or it may turn out that it is. Regardless, once we have a clear understanding of who our customers are, what is their pain points. So we talk about some techniques like user journey mapping, customer research, just maybe plain simple fact of talking to our users, which sometimes the bureaucracy of product delivery sometimes just stands in the way. But all the times in my career where we've had the chance to actually go talk to users or have one of our teammates go understand the user's needs, that has been just always been very rewarding in terms of what their pains are and how our efforts align to that. So to the question of what does it take to build a great product, the short answer is that it's a hard problem, and we just got to trust the process in a way to say, and go talk to customers and talk to users and speak to that rather than to, find ways to use our shiny hammer of AI.
I think about what makes a great product or an ML-driven product. One is that the team, and hopefully it's a cross-functional team, we see ourselves as a customer as well. And I think that's really making it close to building the mindset of what the mindset of the customer. And if the product is being used, I think early indicators maybe could be like we're discovering new things about our customer that we didn't know before because we didn't anticipate. I think those would be really cool indicators of what makes a great product, because your ML-driven aspect of that is automating something really quickly or learning something really quickly and then being able to suggest another decision or assist the end user with something that they may not have been able to do before. And, I think that is where great product innovation comes through. We're just discovering something new and unexpected. And I think that is a great a success indicator.
It seems like experimentation is a bigger deal with these kind of data-driven machine learning sorts of projects. I know experiment tracking and being able to do experimenting in a methodical way is part of it. Do you cover that in the book?
Yeah, absolutely. So we have, in the context of continuous delivery and the path to production, experiment tracking is absolutely a critical part of that. So there was one project that we were on, and when the builds were green, like we had high test coverage, we had model quality tests, then we had an experiment tracking dashboard. So imagine a data scientist has, a pull request with multiple commits. Being able to just go to that experiment tracking dashboard and say, oh yeah, commit 698 was better than the one in production. That gave us that confidence to deploy to production, knowing that it's a better quality model than before. So yeah, it's absolutely a part of path to production for any ML model.
To be honest, I think ordinary non-machine learning software engineering teams ought to do more experimentation. I've seen examples where that led to really effective outcomes, and maybe we could take some of these concepts and apply them back to software delivery in general.
Yeah, and I mean, we have borrowed, I guess, a term we call dual track delivery from simultaneous user experience research and product development as well. The data science research looks similar from a delivery perspective to that user experience research. You'd start with hypotheses and you go and test them, and you're either successful or you're not. But in the process, you need to learn something and keep track of that learning and exploit the upside of that learning in the delivery track, where you're producing stuff rather than knowledge. And so, I think it's a really effective model. Anywhere you're dealing with unknowns or ambiguity or uncertainty in delivery.
I couldn't agree more. I'm currently doing dual track at the moment, and it's kind of nice as well as a team that you're not just doing your BAU or you're doing a long-term strategic feature, but you've got this other track of test and learn. And by the time you get to that near end of, do we know enough and have enough confidence that the following investment to do the implementation is there? And I don't know, obviously there's only so much context switching one likes to do in a day, but I think it gives a breath of fresh air in the terms of portfolio of work a team can do. Yeah.
And just on top of that, on the topic of experimentation, I think it's also a function of the level of trust and safety within the team as well. So sometimes it's awkward or hard to say, this experiment didn't pan out. Like it's like in high trust or high safety team, like we can kill ideas very quickly. We say we tried this, it's not giving us the results we want. We can bin it, and that's okay. Like we are still learning rapidly. It's about how fast we can kill bad ideas, how fast we can learn from those. I remember moving to my first apartment years back before I had a kid, and we used a new place and we didn't have a rubbish bin. And then 2 weeks in, it was like, oh man, there's so much trash everywhere. Not to say ideas are trash or products are trash. I'm saying in the analogy of this house or this apartment, that the inability to chuck things away led to kind of maybe take that in my home, like things lying around. So yeah, I think that experimentation, as you mentioned, Scott, is spot on in how quickly we can experiment, how safely we can, say that, this PR didn't pan out, let's just shelf it and that's okay.
David, it's almost like it's a discipline as well. Like we say experimentation can be fun, but it's actually quite can be a hard discipline for some people, because we can go down to technical components and, a Lambda versus an AKS versus a Databricks, and what do we want to use? But the hypothesis is the overarching thing of like, well, what's our first end-to-end? What's our thin slice that we're trying to achieve? And really that conversation in the team of prioritizing which test or technical spike we want to play first, it does matter, because we're trying to be smart with our time as well.
Yeah, this is exactly what David said in terms of trusting in the process. When the outcome's uncertain, you need to look at the leading measures, such as, do we have a good set of experiments? Are we able to conduct them quickly? And can we exploit the upside quickly as well?
So then what I'm sure is a very easy question is how do you build a great ML team? Because that's harder to experiment with, right? I mean, people don't have feature flags, and it takes a little longer to roll on and roll off and that sort of thing. So, how do you build that team that's going to build the product?
Well, yeah, we look at building blocks of teams as well as products, and so this is the third section of the book focused on building things in a way that's right for people. And so, we ask what's important for teams in general to be effective, but then we also add the lens of the fact that ML's technically complex and requires a lot of different disciplines in a modern product development context. So then we look at elements like trust as foundational. And in this section, we do refer to a lot of existing literature that was, perhaps one of the challenges of writing the book, where to leave some of our insights at a paragraph and point readers to further information rather than have chapters proliferate endlessly. And so in chapter 10 in the book, we look at a range of things like trust. We look at communication. We look at the shared purpose and progress, as we've discussed previously. We look at diversity. We look at all the things that make teams effective in complex, ambiguous environments.
Yeah, I think that's an engineering aspect to your question as well, Ken. So like, how do we as a team experiment quickly? I think it's quite common in the ML engineering or data science world to be caught up in toil of, manual testing of a model's output, or, I think there was a Tecton research from 2023 that said 30% of a data scientist time is used on deployment rather than experimentation. So what we ended up doing for one of the projects we talk about in the book was that when the data scientist has an idea, if I add this feature, it might improve the model quality by X%. They can cut a branch and in their path to production, execute the idea, see the results on the experiment tracking dashboard. Don't have to worry about breaking stuff because tests will tell them that. So that fast feedback afforded from these engineering practices could help them experiment more quickly. And if it doesn't pan out, adding this new feature actually made things worse, fine, just throw that away and try the next thing.
Test-driven development is just as applicable to machine learning projects, I assume, as it is to everything else. What other engineering practices? I know that's David, that's one of your areas. What other practices do you think are important in these contexts?
Yeah. So in in the book, we talk a lot about testing. There's 2 chapters on it, and we kind of take a nuanced view about TDD itself, which I can come back to later. But yeah, we flesh out this kind of typology of tests of an ML system. So we first start to think about what is subjects under test. So in any ML system, there are pure functions, right? Just data transformations, feature engineering. Those lend themselves to unit tests very nicely. But then there's the next part of it is the model itself, which are hard to unit test because even the training of that artifact takes, could be hours, could be 20 minutes, what have you. So then we bring on the lens of model quality tests, and I would think all data scientists are very familiar with model evaluation, metrics like precision, recall, and what have you. But then we take it a step further, and there was an interesting example or exercise in the book where the model was like, 80% accurate. And then we explored the hidden stratification problem where what if for some subclasses, actually the model wasn't 80% accurate. So then we wrote a test, we ran it, and it was like a lone default prediction example. And it did turn out that for some occupations, the model, yes, was like 80 plus above the threshold. But for laborers, it was like 50% accurate. So we discovered this kind of type of errors that was happening to a sub-segment of that data. So that model quality test and stratified metric tests brought that in. In the ML system, there's only so much you can test, and there's a part of it that's also just production monitoring. As this thing is operating in the production or as a shadow model in production, then being able to collect real-world data. Say the model said, yes, this loan application is likely to default. Then collecting data on whether it did default or what's the risk profile over time, being able to monitor that in production was important. It's not monitoring as we know it, like real-time monitoring. Sometimes it's the batch or latency depends on how quickly we can label those ground truth. But still, it's going to give you that feedback about the quality of that model. Yeah, so a lot of engineering fun in ML systems, and it was just quite striking to us how I think we have the fortune of sitting in the intersection of software engineering and machine learning. So we could kind of take practices from both worlds. Actually, there were some parts where we found that some engineering practices didn't always pan out. And maybe this is where I'll circle back to TDD. So there were some cases where TDD wasn't going to give us, or test-driven development doesn't give us that fast feedback. So then at that point, it's like, it's fine. If it's not giving us the feedback, we don't have to be dogmatic about practicing it. So actually it's dogma in both ways. It's like either dogmatic in that, yes, I have to TDD, or like the other dogma is, no, it's machine learning, you can't TDD. And the truth is more nuanced. So it's like being able to know when you cannot get that fast feedback. So yeah, it was interesting to really stretch the limits of these software engineering practices and see when it breaks down and, add on some ML specific engineering practices.
Perhaps more than any other area, I see practices that are common, but they're slightly renamed. So it's like, DevOps is now MLOps, and continuous delivery is continuous delivery for ML, is a process inside Thoughtworks. Is that positioning, frankly? Is that to say to data scientists, hey, don't worry, we're thinking about you? Or are they radically different engineering practices? Is there crossover? How much do people need to know if I'm an infrastructure engineer and I'm now going to be on an ML team? Do I need to go study ML ops, or am I going to apply most of my DevOps?
Yeah, that's a great question, Ken. So I think there are ML specific extensions in the ML ops space. So it builds on top of DevOps, things like infrastructure as code, deployment automation, scaling infrastructure essentially for training or for inference. But ML ops then brings in those ML specific components like in being able to have a metadata or model registry for every deployable, because it's no longer just code. It's also this really gigantic model sometimes. Then also things like feature store. So it's not just compute or logic at runtime, but also what features need to be available at low latency in production. So I think being a DevOps engineer gives us a really good background and starting point to understand a lot of this. And it needs to be augmented with, ML specific or ML ops specific practices.
I also see those namings is to be one, inclusive and inviting. I think it's a really exciting space, and lots of people may be coming from career changing and straight into this space and not from the traditional software delivery. And I think being able to extend the name with ML ops, for example, it's to say that there is a whole body of knowledge that is tried and tested, lots of experienced practitioners with points of view, and you don't need to go through the one-track pathway of having a PhD or go through tertiary studies, for example, to be an ML engineer. There are building blocks and that on the software delivery landscape that can lend you to being in this space and, be part of this community. I think we do need to keep growing this community with different perspectives and different shaped people, because that's when our models are going to be richer and less biased as well.
I know you started this book back in the dim past before Gen AI became the central feature in all of our lives. But I wonder, I know it's applicable and we're still doing a lot of that more traditional, if you can call it that, machine learning. Do these techniques and this approach also apply when we're talking about generative AI?
Yes, they do. As I said earlier, even if you're consuming a Gen AI service, such as an embedding service from OpenAI, it really helps as the team to understand what's gone into training that service, how it actually performs, and what its failure modes are. Because any ML service will have some degree of unpredictable behavior or some less than perfect performance. And so being able to design products with those failure modes in mind is very important. But they offer a lot of advantages for solving otherwise difficult problems with complex data as well. So it's not to say that the failure mode should drive your thinking. And so another aspect, and I think we touched on it a little bit about successful products, is that a lot of conversations we're seeing, Gen AI is a great trigger, and it's a really the right intuition is there that this is a problem that can be solved with AI, but it's not necessarily the most effective technique, the most efficient or the most architecturally ideal technique to use to solve a particular class of problem. And so this product development approach of testing and learning, teams being able to potentially prototype with Gen AI first, but then if they identify there's a better solution for a digital product when it goes into production, when it moves out of that realm, that you can handhold the solution. So then teams being able to identify the most appropriate traditional ML or AI technique, as we might describe it, to support that feature in a production environment. It's very important for teams to be able to make that pivot as well.
And on that question of do any of these apply to Gen AI, in addition to what Dave has shared, I think there's a whole swath of things to say about product testing and all of that. But to zoom into engineering for a little bit. So we were lucky in the timing of this, one of the chapters on automated testing, that we were on a project to develop a LLM prototype. And we were actually able to TDD or apply test-driven development in the prompt engineering of one of the LLMs. And it was really fun and low cognitive load to be able to say, these are the scenarios that I need my LLM to handle, or LLM plus my prompts from design to handle, and be able to just iteratively refine our prompt design to kind of pass one scenario at a time. That fast feedback was really good. And then sometimes the stakeholders will say, I need to add this new thing, or can you make this chatbot more polite or something like that. The ability to change that prompt and then run a test suite of 10 to 20 tests or scenarios and say, oh, everything is still green. Like that really helped us move really quickly. And I can imagine if somebody one day needs to deprecate GPT-4 to support a newer version, the ability to just run the whole suite of tests to say, yeah, it was still as good as before, or it starts to fail in these scenarios. I think this engineering practice definitely will help those LLM application areas.
You know, I have so many more questions I would like to ask, but we're going to run out of time. And in wrapping up, I'd like to give each of you an opportunity to tell me, tell the audience what is the most important takeaway from your perspective. Dave Colls, let's start with you.
So I would say that when it comes to building ML products, there's a role for everybody in a modern digital organization. And this book tries to articulate how each person, regardless of their background and experience, can play a role in delivering great ML products.
David Tan, how about you?
I would say my key takeaway in building effective machine learning teams is just to be able to reflect on your past week. What has worked for you? What hasn't worked? Just to be able to be sensitive to those smells and signs that there may be a problem underneath. For example, if I spend 3 days manually testing something before a release, I don't like that feeling. It was tedious. Then that's a signal to us that something could be improved. So yeah, just to look back at your week as an ML engineer, as a data scientist, like what frustrates you? Whether it be in the product space, user space, engineering space, or data science space, what's annoying you? And then just to seek out other ways or better ways of handling those scenarios.
Ada?
Thinking of a succinct way to answer this, and I'll try my best. And I'll start with, it's all about the bigger picture. It's all about the problem and the value we're trying to solve and deliver. And our principles and practices in software delivery and engineering is all applicable to this. And that is what will help us make ML products successful.
Thank you. I think that was a really good answer. Where can we find the book?
Yep. We'll add it in the show notes, and you can go to your favorite search engine and type in effective machine learning teams. That will bring you to O'Reilly, or you can order on Amazon, Booktopia. We've heard from a publisher that in North America is also in Target and Barnes & Noble. So that's, to me, very cool. But yeah, you can find it in your nearest search engine.
And there's a hard copy floating around the office, I noticed, which was very exciting. I'm sure to have it in your hands. Yes.
Yes. Yeah. That was courtesy of Dave for the Melbourne office.
Well, and for what it's worth, I can tell you that the technology section in the Barnes & Nobles here in North America is very small. So that is high flattery for you as authors.
Woohoo!
You need to do a tour, obviously.
I'll be up for it.
Okay, thanks everybody. This has been a great conversation, and I hope everyone will go and read the book and consider applying some of these techniques in their own work.
Yep. Thank you so much, Scott and Ken.
Thank you.
Everyone. Thanks, Scott and Ken.